If you're watching this video, you've probably already watched several other videos comparing Unity, Unreal, and maybe even the Godot game engines. However, this video is going to be completely different from all those other videos in two massive ways. First, I'm going to pour gasoline all over the game engine flame wars by making the unprecedented claim that there is one single key factor you should consider when choosing which game engine is right for you. Then I'm going to go full nuclear by explaining why I think all the other criteria people normally point to when talking about choosing a game engine is not only wrong, but actually hurts new game developers in the long run. So get your burn suits ready because I'm expecting that comment section to be flaming hot. And just in case that wasn't enough, the second way this video is going to be different from all the other comparison videos is that I'm actually going to walk the walk as opposed to just talk the talk. Starting tomorrow, I'm going to start building the same game in all three game engines. I upload videos every single day, so I'll document my experience with all three engines in real time, giving a true side-by-side comparison. I'm going to cover all the details for that project in my video tomorrow, so make sure you hit that subscribe button and turn on notifications to guarantee you don't miss a moment of that journey. Now let's get to the heart of this video. What is the most important factor when choosing a game engine? To answer that question, let's take a step back and point out something that is both completely obvious and also seems to be completely ignored when talking about game development. Video games are computer programs. Like I said, this is completely obvious. However, when people talk about how to make great video games, they almost never talk about video games in terms of computer programming design best practices, which is actually kind of nuts. Any game more substantial than a game jam project will be a reasonably complex piece of software. If you were learning to build an equally complex program in any other well-established field, it would inevitably lead to conversations about design patterns, frameworks, separation of concerns, etc. However, if you're a game developer, there's a good chance you have no idea what I'm talking about, and right now you're bored out of your mind. To a certain extent, this is understandable because programming design is nowhere near as interesting as the sexy parts of game development like game design, game mechanics, graphics, etc. However, ignoring program design best practices is pretty much guaranteed to prevent you from ever completing your dream game. Here's why. The more complex a program gets, in this case your video game, the more difficult it becomes to manage assets, troubleshoot problems, and make updates to the program. Therefore, as your game progresses, you will eventually reach a point where every change you want to make to your game will require hours of reworking existing code and cause a cascading avalanche of bugs. In order to deal with this challenge, programmers in every field build sets of best practices that allow developers to efficiently build more complex programs while minimizing collateral damage from updates and changes. Therefore, when building any game beyond a game jam project, you have to invest your time in one of three places. First, you can invest your time in learning the best practices for managing program complexity and implement those best practices in your program or game yourself. Second, you can find a framework or tool chain that implements those best practices for you, spend your time learning that framework or tool chain, and use that to build your program or game. Third, you can spend your time beating your head against the wall in frustration, trying to deal with an increasingly unmanageable mess. If you're just getting started in game development, understanding this choice is probably the most important thing you should know that nobody ever talks about. If you want to move beyond game jam games, then you're going to have to put the time into one of those three places. The only question is where. And since this isn't a topic that people talk about in game development, most people end up in the default third option of beating their head against the wall in frustration until they quit rather than ultimately building their dream game. So what does this have to do with game engines? Well, as it happens, there is a clear line in terms of option 1 and option 2 when it comes to game engines. Unity and Godot are pretty much blank slates when it comes to program design. In order to build more complex games in these engines, you're going to have to learn best practices separately and implement them into your game development yourself. Unreal Engine, on the other hand, was built from the beginning to build AAA games and designed around best practices that have been battle-tested in several large-scale AAA games. This doesn't mean you can't make a mess of a game using Unreal Engine. You absolutely can. However, the engine itself is like an instruction manual in how to build a good game. The more you learn how to use the engine as intended, the more complex games you will be able to build and the faster you will be able to build them. This distinction is way more important to your choice of game engine than any list of features or performance metrics because it plays a massive role in your experience as a game developer. Furthermore, failing to understand this distinction is also why most people, when talking about how to choose a game engine, say things about game engines that are often incredibly misleading for new people. For example, Godot and Unity are often described as beginner-friendly, while Unreal Engine is often said to have a steeper learning curve. However, when you view those statements through the distinction above, you quickly realize how much these statements miss the point. When learning Godot and Unity, you will start building things much faster faster. However, many of the things you'll end up building will be simpler versions of features Unreal Engine offers out of the box. With Unreal, a beginner will spend more time learning what the engine can do for them rather than building it themselves. If you're just getting started building video games for fun, the instant gratification of doing something in Godot and Unity might help keep you motivated to keep learning new things. However, Godot and Unity users are also much more likely to default to option 3 and end up stuck spinning their wheels later in development when every little change they try to make to their game requires hours of refactoring and creates mountains of bugs. Learning how to use Unreal Engine can feel slower at times because you're not building things yourself. However, the tools you're learning to use would take you an extremely long time to build and battle test yourself, so once a beginner learns to use these tools, they'll be able to build much more complex games than if they tried to build the same things from scratch. The flip side of this is that you gain a much deeper knowledge of how a system works if you build it yourself from scratch. Therefore, if Godot and Unity users do take the time to learn best practices and build them into their games, they will have a much more detailed understanding of how their game systems work at every level compared to an Unreal Engine developer that just learns how to use the existing systems. So beginners in Unity and Godot will start building things faster than beginners in Unreal, but beginners in Unreal will be able to use more powerful tools much faster. I would argue Unity and Godot actually have a steeper learning curve because you have to learn how to build the systems yourself rather than just learning how to use them. However, you won't realize how much you're missing until much later in the process. Finally, while Unity and Godot have a much larger room for error, they also offer a greater potential for learning the full depth of good programming design for games if done correctly. They also give you more flexibility in building that programming design exactly how you want to use it. The point here is that both of these routes are distinctly different, but both are capable of either developing great games or leading you down an endless road of frustration until you quit. The key to avoiding much of this frustration is to recognize from the start that building more complex games requires a time investment either way, and then choose the game engine that aligns with how you want to make that investment. If you're working with Godot or Unity, take the time to figure out the best practices early on so that you develop good habits in your programming design. If you're using Unreal Engine, understand that even if you're not building the complex systems yourself, they will still empower you to build more complex games over time. I really think this is the most important factor when choosing a game engine, and it gives you a clear choice to make between engines. Do you want to learn the best practices for game development on your own and build them into your games yourself? In that case, use Unity or Godot. Do you want to start with tools that have best practices already built into them and then learn how to use those tools to build your game? In that case, use Unreal Engine. All of this being said, I'm positive that there are plenty of people that are going to passionately disagree with me on this. If you're one of those people, hopefully you'll take the time to passionately disagree with me in the comments below. However, I think most people's objections are going to stem from the same generalized argument. In the conventional discussion about game engines, it is common to say that a specific game engine is best for a specific purpose and that you should use that game engine for that purpose. I think this is the wrong way to choose a game engine, and more than that, I think it actually hurts new game developers. The reason why this is a problem goes to the broader principle underlying the main idea for this entire video. That broader principle is that you shouldn't make long-term decisions based on short-term factors. If you're just starting out in game development, you likely have no idea where your journey is going to end up. Even if you have a game or genre you want to build in now, it's possible or even likely that this will change as you learn more about game development. Even if you do end up building the exact game you want to build now, what about the next game or the one after that? Let's say you move on to your next game idea and everybody says a different game engine than the one you're familiar with is the best engine for that type of game. Are you going to switch engines and spend the time and effort to learn a whole new engine, or are you going to figure out how to make it work with the engine you're already familiar with? In almost every single case, the answer is you're going to stick with your existing game engine because whatever minor benefits you might get specific to the type of game you're building, they pale in comparison to the hours you'll have to spend learning the new engine. So if it doesn't make sense to switch game engines based on whatever project you're working on in the future, why would it make sense to choose a game engine in the first place based on whatever project you want to work on now? The answer is that it doesn't make any sense. And yet the factors that most people suggest you choose a game engine by are generally only relevant to the specific point you are currently at in your game development journey. Your relationship to those factors will almost definitely change as your journey continues. So rather than make the decision of which game engine to invest your time in based on where you are in your journey today, I'm suggesting that you should instead make that decision based on what kind of journey you ultimately want to have. Now, I'm completely positive that despite everything I just laid out, there are still people who will say, yeah, but if you're doing X, you absolutely have to use engine Y. Some of the most common examples are 2D and mobile in Unity and multiplayer in Unreal. I was going to cover these specific examples in this video, but it was starting to get a little long, so instead I'm going to address these specific use cases in a follow-up video. When that video is done, I'll put links in the description, the cards, the pinned comments, etc. I'm also going to cover programming languages either in that video or a separate video because it's kind of a pet peeve of mine. Spoiler alert, absolutely do not choose your game engine based on programming language. I'll explain why in the follow-up video. But again, if you object to anything I've said in this video, make sure you put your thoughts in the comments below and I'll cover them in the follow-up video. Finally, as I said in the beginning of this video, starting tomorrow, I'm going to be building the same game in all 3 game engines. I put up videos every single day, so you'll be able to follow along with all the progress for that project. Make sure you subscribe and hit the notifications bell so you don't miss out on anything. As always, thanks for watching and I'll see you tomorrow.